pick it up. So today we're gonna learn how to bomb our web services via a tool called K6. Next slide. Okay. A few words about me. I'm Apostolos Kalvelonis. I'm a senior software engineer, and I work primarily on the fintech sector. Right now, I work for a wealth tech company in Abu Dhabi, and I'm also a founding engineer in a Web3 project. Right before, I was working as a software engineer for a crypto platform in the UK, and also I worked as a full-stack engineer in related finance products related to blockchain and open banking. My stack is Node.js, TypeScript, and I do some front-end as well. And overall, I'm not limited to the JavaScript ecosystem. I like to get my hands dirty with new technologies. The agenda for today is separated in 3 parts. We're gonna discuss a little bit about why we should do load testing and what exactly is it, what is K6, and we're gonna see a practical example as well. So let's talk about load testing. But before that, let's take a few steps back and check the known tests that we currently do. We know unit tests, where we test isolated components, like really small pieces of code where we check very small functionality. For example, we have a cart and we check whether if the total amount is equal to something, so we can apply a discount there. If we zoom out a little bit, we have end-to-end tests, where we pick one specific user flow from the time the user clicks on the browser, how the click is gonna pop an event and interact with the server, and what it's going to return. And if we zoom out a bit more, we have load tests, where we check the performance and the stability of the whole software ecosystem we have built within a deployed environment. Which means that we also check, for example, what happens if we have a big load of users. Will it scale out, or we're gonna have some memory leaks? And basically, yeah, the reason is that some bugs only appear when we have a big load of requests. And what exactly can go wrong? So we have some bad things that can happen. If we haven't taken into account concurrent writes, we can have corrupted data. We can also exhaust our resources. Think about memory leaks. And there can also be some other big monsters like deadlocks and retry storms. And apart from that, from my experience, is that load testing can also be used as a communication tool. Us, as engineers, we love to optimize code. We love to refactor and say, hey, if we change this, we're gonna get some big impact. We're gonna improve the performance. But the thing is that we don't offer something tangible to the upper management with exact numbers of what exactly is going to change based on our changes. And thus, if we use load testing, we can gather information, we can generate proof, and go to the upper management and say, hey, if we tackle this technical depth, we're gonna definitely have some improvement on the performance. Now, let's move on the different types of load testing. On the y-axis, we have the throughput, we have the users, let's say, and then on the x-axis, we have the duration of our tests. We're gonna start looking at them from the length of the duration, but we're actually gonna start with the smoke test because it's the simplest one. With smoke test, we just validate that our service runs as expected. And also our test runs as expected. It's like the happy flow to see that we can actually now go and bomb our service. Moving on, we have our spike test. Here, we just put as many users as possible, let's say 10,000, and we try to see how the service is going to behave. Is it going to actually scale out in order to manage for this new load? And after that is done, will it scale down as well? Meaning that it started running with 1 instance, it went up to 3, and then it should probably go back to 1 as well. Moving on, we have the average load, where we should know what is the average load on an average day. We use those numbers for the users. And if we don't know those numbers, we should either wait a little bit and actually gather the information from it, or use some back-of-the-envelope numbers. Moving on, we have the classical stress test. We now work close to the instance rates. For example, if we are about to have a really good weekend deal or a Black Friday deal, we should expect a huge bump of users. Then we have the breakpoint test, where the point of this test is to actually fail. We know that we're going to see errors, and what we want to do here is investigate and actually find at which point, roughly, our service breaks. And finally, we have a soak test, which runs for hours. This one can run for at least 4 hours, and the reason is that a lot of software introduces errors and issues after a certain time, in a sense, after some usage has happened. Imagine memory leaks, imagine that disks start to gather information and doesn't clean properly, bad garbage collection, etc. This slide just has everything we have talked about, nothing new. Yes. Okay, cool. And now let's move on to the tool we're going to use today. It's called K6. Does anyone know Grafana? Hell yes. Okay, a lot of people know Grafana. That's great. So Grafana is an open source monitoring tool, and basically the company behind that, Grafana Labs, is also the maintainer of K6. And the reason why I'm trying to sell K6 to you is because you can write JavaScript, but you get the performance of Go. So imagine that your tests run way faster than if you used plain JavaScript. And it also has a good ecosystem in the sense of you can add a lot of plugins. It has built-in browser module, which we will check later on. And it also has CLI tooling, meaning that you can be part of your pipelines. And if we want to check some high-level things that you can do with K6 is, for example, okay, let's say that we have 10 users. I want those 10 users to hammer the checkout endpoint nonstop for 30 seconds. I don't care about the number of requests. It can be 10K, whatever. Just hammer it and let's see what happens. Or you can play a little more with it and you can say that, okay, I want to start with 3 users hammering per second, then go up to 50, and then go down to 0 again. A minimal practical example of how this looks like is quite simple. So, of course, we import the moduling at the top, and then we have the options. Here at line 5, we have the number of users that we're going to use and the duration of the whole test. The default exported function is what each one of those users is going to do nonstop. So what's it going to do? It's going to do a GET request at a specific endpoint. And we will also check and validate that the response we got is a 200. I have also uploaded a video here about how this looks like. Let's slow down a little bit. Okay, so you run it. I don't block it, okay. You run it through CLI. We can see here that you get a bar at the bottom showing where you start with your users. I have skipped the time. We can see that by the end of it, around 40K requests have happened. And in the end, we get a summary of what we got. For example, we see that the average request was about 1 second. We get the minimum, the medium, and also some fancy numbers for SLAs like the P90 and P95s. The browser module is also quite simple. The only difference is because we need to define options that the type of browser we're going to use is Chromium, we have to wrap it in this field called scenarios. Scenarios is a configuration where it allows you to run different tests in parallel. And this is the reason why here in the exec, we also define that we're going to use UI test, which is the name of the function. Executor is different profiles that users can use. Here, the per view iterations, it means that each user gets a fixed number of iterations, meaning that we have 5 users, we have 3 iterations, so we're going to have 15 requests. And also, the way the interaction works is pretty similar. We just get the classic selectors. You can also use class names and interact with it. And moving on to the demo. So for the demo, I created a splitwise clone. For anyone who is not aware of what splitwise is an expense application that you can use with your friends. For example, you go on a trip and you wanna split the expenses. For example, in the end, instead of sending money to each other, you have all the expenses there, and it simplifies things. I used Express and Postgres at the backend. Of course, I vibe coded it. And the frontend is just a Next.js application. And now I'm going to show you how this looks like before we start running tests against it. So yeah, it's a classic UI, vibe coded UI. We have the groups here. We have the trip to Paris. We can add members. You see the balances. You can add new users, and you can interact with the wallets. For example, I go to Alice, and I add $50. And for easiness, I have also created a button here that seeds and resets the database, so it's easier to test. Moving on, I'm going to show you 3 different scenarios, expenses, race, and pool, different problems that may appear. The first one is more about showing the browser module and how interaction works, and the other ones are some bugs that doesn't pop up, let's say, in the regular tests, and they may happen in cases where you need load testing. We're not gonna use the video; it's like a fallback in case. For the expenses, we are going. Yeah, I wanted them to test expenses. Yes. Okay, now it goes and hammers. Basically, we see that it starts adding expenses there. There are 3 tabs, actually. You can see that more than one opened. It interacts. Let's wait for it to finish. So it finished, and once again we get the number. The total was 15 because we used per view iterations and some numbers for that as well. We're going to see the configuration we're going to use for the next one, which is the race condition. Let me get up for this. So at the top, we're defining a counter. So in order, you can also use counters, which are used here at line 11, thresholds, that depending on conditions, they're gonna exit the execution with 1, for example. So it can be part of your pipeline, because the execution won't end with 0. Here, yes, once again, we define that we want 10 users with 10 iterations, meaning 100 total. We have defined our thresholds, and let me go a little bit. No need. So also, each file of K6 has specific names for test lifecycle functions. For example, the setup function is going to start at the beginning of your test, independently of the number of your users. It will run exactly 1 time. And the function that every user is going to run is simply pay a post request to a URL with the amount of 10. Here we're not going to use the UI because it's more friendly to my weak laptop for this. So that's why I'm going to interact. I made this calling the server directly. So npm run test race. So what do we get here? Let's take it part by part. So the seed succeeded. The pay was everywhere accepted. We've got the get a request of 200, but we see that the threshold on metrics have been crossed, and it exited with 1. What does this mean? So if we go and check the actual test, which is race condition, we first of all pick a specific user. You have a question? Zoom, okay. So we pick a specific user, and each one of the virtual user, meaning each one of the executors, is going to use that specific user. So if we go back to refresh this, if we go back, we see that every balance is 1,000, meaning that if we did 100 requests of 10, it should have been the total balance of Alice should have been 0. Meaning that we have a bug in our program, which if we go with a regular flow, we wouldn't have seen it, like a simple request of just deducting amount. If we have time, I can show you the bug later on there, but in order to save time, I will move on to the next one. So here, we check the, also in the end, apart from setup, we have in the end a function called teardown, which basically does in the end check whether if there is a race condition or not, meaning that the counter that we generated at the top of the previous of the file, it is more than 1. We showed this, and then we have another test which actually starts with at the first 5 seconds we start with 50 users. Up to 15, it goes to 10, and then for the last 5 seconds, it goes down to 0. And all it does is just a post request deducting $1 from the user's balance. So once again, let's run this. We see that the numbers start rising, going up and up and up. And after a while, it starts getting errors. We see that 2 of them actually rejected. And the reason here is that I haven't configured properly the database, precisely the DB I used here, the connection timeout is 30 milliseconds, which is super low. And if we bump this, we will actually see that all of our requests succeed. So, takeaways. We are at the end of the presentation and we're going to have the questions soon. First of all, we can find issues with load testing that other tests don't. It can also be a communication tool if we try to sell it at the upper management. We do write JavaScript with Go efficiency, and also AI makes it basically more accessible than ever. So if there is a need to onboard on load testing, it can now become easier than ever. And that's it. Now, any questions?
First of all, the word accessible here was literal, was not regarding accessibility.
Sorry?
You used the term accessible, but you didn't mean accessible in terms of accessibility.
No. Yeah.
Easily available,
Yeah,
okay.
basically that you can now play around with it.
I have a question regarding how do you integrate it in your CI/CD pipeline?
Mm-hmm.
Because this test can be expensive to run. So what is one of the best approaches Do you have any cron jobs, any schedulers, or do you do before you merge a PR? And yeah, what
So the thing is that it is running load tests is quite expensive, not in a sense of it being part of your pipeline, but you have to do a cleanup later on. So you would run those. You would run a load test under to an environment that is as close to your production as well. It shouldn't be your production. There are cases.
way of staging, for example?
Exactly, yes. So you can easily clean it up later on. Being part of the CI is not that expensive unless you do a soak test, for example. Otherwise, yeah, you can. For example, the way I used it was I set it up on my machine and I was just hammering the staging environment of my experience.
Run it on demand.
Exactly, yeah.
Set it up on, I was
Yeah.
wondering in a production system, where is the right place in the whole pipeline, to...
Yeah. Yeah, it should be on demand, and also the thing is that if you are at a startup and you're still validating where your product fits, it shouldn't be your concern. Yeah, when you move on to being a scale-up and you know what your users want and how they interact with your application, you know your numbers, then you can hammer it. Any other questions? Okay, thank you.
Today's the day of testing, actually.